Right now, the heat dome is doing something meteorologists didn't expect this late in August. It's not weakening, it's expanding. From Texas all the way to California, this ridge of high pressure has been building for days, threatening records across a stretch of the country large enough to span 3 time zones. Forecasters have a specific phrase for what this air mass has become. Steamy, even by the standards of an August that's already produced 2 record-shattering heat domes before it. But here's the part of this story that actually matters most. Every heat dome this powerful eventually collapses. And when this one finally does, it isn't going to fade away quietly. It's going to trigger something else entirely, something meteorologists are already mapping out days in advance. So what exactly is holding this heat dome in place right now? Why is it still growing instead of breaking down? And what happens the moment it finally lets go? The third dome of a summer that wouldn't quit. To understand why this particular heat dome carries so much weight, you need to see where it fits into a summer that's already been brutal. This is now the third major heat dome to grip the central United States this year. The first, arriving around the 4th of July, killed at least 44 people in a single week, including 29 in New Jersey alone, a 15-year state record for that state. Atlantic City hit 106 degrees on Independence Day, tying its all-time record and triggering thunderstorms violent enough to knock out power to roughly 250,000 customers in New Jersey and force the cancellation of 4th of July celebrations in Washington, D.C. and Philadelphia. A second dome followed, pushing records across the Rockies in the west, with Salt Lake City and Billings, Montana both setting all-time temperature records of their own. And now, before officials have even finished tallying the toll from those first 2 events, a third has arrived, this one settling over the south-central United States before expanding westward into the southwest and California. More than 80 million people are currently under extreme heat warnings or heat advisories. The National Weather Service's own Weather Prediction Center, an agency not known for dramatic language, described this specific air mass in blunt terms. Steamy, even by mid to late August standards, a season when steamy is already the expectation, not the exception. Daytime temperatures are pushing into the triple digits across a stretch of the country running from central Texas through the desert southwest, with overnight lows offering little real recovery in many of the hardest hit cities. Why this dome won't just fade away. Here's the mechanical detail worth understanding, because it explains why this heat dome has been expanding rather than weakening the way late August heat usually starts to. A heat dome forms when a large ridge of high pressure stalls over a region, acting essentially as a lid clamped down over the atmosphere. Meteorologists often call this configuration an omega block, named for the Greek letter Ops, that the pattern traces across a weather map, a high-pressure ridge flanked by 2 areas of lower pressure on either side. That shape isn't just visually distinctive, it's mechanically stable, which is exactly the problem. An omega block tends to resist the normal west-to-east progression that moves most weather systems along within days. Instead, it can lock in place for a week or more, continuously sinking air and suppressing the cloud cover and thunderstorms that would otherwise interrupt. The heat buildup underneath it, essentially insulating itself against the very forces that would normally break it apart on a predictable schedule. That's precisely what's allowed this current dome to keep expanding rather than collapsing on schedule. As of this week, the ridge-driving record heat across Texas and Oklahoma states that R, in the words of forecasters, no strangers to extreme summer heat, has continued pushing its influence westward into the southwest and California, rather than the more typical late August pattern of heat gradually retreating as the jet stream reasserts itself further north. Ben Knoll, a meteorologist tracking the event, has described it plainly as a powerful heat dome that will drive record heat across the southwest through the end of August, a forecast that pushes this event well past the point where a typical summer ridge would have already broken down. The collapse. That's already being forecast. Even the most stubborn omega block eventually breaks down, and forecasters are already tracking exactly how this one is expected to go. The mechanism is almost always the same. A ripple develops in the jet stream, the fast-moving river of air-steering weather systems well above the surface, and that ripple gradually works its way into the stalled ridge, disrupting the stable pattern that's been holding the heat dome in place. As that disruption takes hold, the sinking air that had been suppressing thunderstorm development weakens, and the atmosphere, still loaded with heat and humidity accumulated over days of the ridge sitting in place, suddenly has room to do what it's been unable to do. The entire time the dome held firm, releasing days of pent-up instability all at once, rather than in the gradual, manageable bursts a normal summer pattern would produce. Forecasters describe this transition specifically. As the heat dome weakens, thunderstorms have an easier time erupting throughout the central and eastern United States, and some of those storms turn severe. A complete pattern flip becomes likely especially across the southeast, as that jet stream ripple develops and lingers, triggering an eruption of showers and thunderstorms on a daily basis in some locations that had gone rain-free for the better part of a week or more. A genuine whiplash for communities that had almost forgotten what a cloudy sky looked like. Why breaking down doesn't mean getting safer. It's worth being direct about why this collapse is being treated as its own hazard, rather than simply the relief everyone under these heat warnings has been waiting for. Days of trapped heat and humidity don't just evaporate the moment a ridge weakens. They get released, and the atmosphere sitting underneath a collapsing heat dome is often primed with more stored energy than an ordinary summer thunderstorm setup would ever produce. That's the same mechanism this series has tracked play out repeatedly. Across this exact summer, an Indiana flood that broke a 113-year-old river record after a stalled front collided with heat-fueled moisture. Extremely critical fire danger across the Great Basin and Pacific Northwest as wind arrived right on top of vegetation. A previous heat dome had spent weeks drying out. Record territory heat maps turning an unprecedented color across California, followed immediately by elevated fire risk across the Sierra Nevada and southern California's coastal ranges. Even Britain's own summer followed a version of the same script, 6 separate heat waves compounding into a nationwide drought rather than any single dramatic collapse. Proof that this underlying mechanism isn't confined to one country or one specific outcome. Each of those was the same underlying pattern, a heat dome collapsing and handing its stored energy directly to whatever hazard the local terrain and atmosphere were primed to produce. For this specific dome, spanning Texas to California, forecasters are watching 2 distinct possibilities as the eventual breakdown arrives. Severe thunderstorms and flash flooding as the ripple works through the central and eastern half of the country, and continued, even intensifying fire weather risk across the drought-stressed interior western California, where weeks of this summer's repeated heat domes have already left vegetation critically dry. The detail meteorologists keep repeating. There's a specific warning forecasters have been careful to include every time they describe this kind of transition, and it's worth repeating directly rather than glossing over. For those bracing for another round of weather whiplash after enduring this dome's peak, meteorologists have noted the return of thunderstorms and downpours should generally be less extreme than the heat dome itself has been, in most cases. That's a genuinely reassuring detail. But it comes with an immediate caveat. Flash flooding risk doesn't disappear just because the overall pattern is less extreme than the worst-case scenario, because that risk tends to accompany summertime thunderstorms regardless of how the broader pattern compares to history. A single slow-moving storm cell, even inside an otherwise unremarkable severe weather setup, can still produce the kind of concentrated, fast-developing rainfall that overwhelms drainage in minutes, especially across ground baked hard by the exact heat dome that's finally breaking down above it. What the death toll from earlier domes actually teaches us. It's worth pausing on why officials are treating a third heat dome arriving, before the toll from the first 2 is even fully counted as a genuine public health compounding crisis. Not just an unfortunate coincidence of timing. Heat doesn't affect the body as a single, isolated event. Repeated exposure across the summer with minimal recovery time between dangerous stretches compounds physiological stress in ways a single, isolated heat wave doesn't produce, particularly for older adults, people with cardiovascular or respiratory conditions, and anyone without reliable access to air conditioning. Meteorologists have been direct that a third heat dome landing this close behind the first 2 represents exactly the kind of repeated compounding this series has tracked across multiple regions all summer. Whether that compounding shows up as accumulated heat stress in vulnerable populations or as accumulated dryness in soil and vegetation that turns the eventual collapse into something more dangerous than a single isolated event would have been on its own. There's also a policy dimension worth noting. A bipartisan group of senators and representatives introduced the Extreme Heat Emergency Act, specifically in response to this pattern, aiming to add extreme heat to the list of federally recognized disasters under the Stafford Act, a designation that would allow FEMA to respond to heat emergencies with the same federal disaster framework currently reserved for hurricanes, floods, and wildfires. That legislative response is itself a signal of how seriously officials are now treating repeated, compounding heat domes as a genuine, escalating category of disaster rather than simply an uncomfortable summer. Inconvenience, a recognition that's arrived only after this year's specific, repeated pattern made the case impossible to ignore. What living under an omega block actually feels like. It's worth painting a fuller picture of what this specific pattern has meant on the ground, because record heat, as a phrase, tends to flatten what's actually been an unusually punishing stretch for the people living through it. Under an omega block this stable, The same handful of cities wake up to nearly identical forecasts day after day, triple-digit highs, minimal cloud cover, and overnight lows that barely dip enough to register as relief. Cooling centers across Texas, Oklahoma, and now the expanding edge of this dome in the southwest have stayed open longer and later than usual, and utility companies have repeated the same conservation requests they issued during the first 2 domes earlier this summer, watching electricity demand climb toward its highest points of the year as air conditioners run at capacity across an enormous stretch of the country simultaneously. For outdoor workers, agricultural laborers, and anyone without reliable indoor cooling, this isn't a single bad week. It's the 3rd such week this summer, arriving with progressively less time to recover between rounds. What actually happens next? So here's what genuinely matters going forward, beyond any single day's temperature forecast. Watch the jet stream specifically over the coming days, since the ripple that eventually disrupts this omega block is the single detail that determines both when this heat dome finally breaks and how violently that breakdown unfolds once it does. Watch the southeast and central United States for the severe thunderstorm and flash flood risk forecasters have already flagged as the most likely consequence of this collapse, particularly across ground that's spent days baking under record heat with essentially no rainfall to soften it. And watch the interior west and California simultaneously, since this dome's westward expansion means the eventual handoff to fire weather risk could arrive across exactly the terrain already stressed by this summer's earlier heat events, layering a 3rd round of danger onto ground that's had the least recovery time of anywhere in the country. A heat dome this size doesn't simply switch off, it collapses, and when it does, it hands its stored energy directly to whatever the local geography is primed to turn it into. Floods in one region, fire in another, sometimes both within the same forecast week. That's the part of this story that matters more than any single record temperature this dome eventually produces. The heat is dangerous while it holds. What triggers the moment it finally lets go is where the real story of this summer keeps writing its next chapter. And if this year's pattern holds true to everything that's come before it, that next chapter is already being drafted in the jet stream, days before anyone on the ground feels the first drop of rain.